So let's just quickly begin with a quick introduction of AI. There's a bunch of different definitions, so I pulled a few here together. NASA says it's artificial intelligence, refers to computer systems that can perform complex tasks. The idea here is I'm highlighting complex tasks. That's one theme. Stanford's AI Research Lab says it's a simulation of human intelligence, so it's bringing in this human element. The process includes learning, reasoning, and I want to also highlight self-correction, the ability to adapt to new environments and new changes. Then Niels Nielsen, a computer scientist and author, says that artificial intelligence and activity is devoted to intelligence that quantifies an entity to function appropriately and with foresight into its environment. So there's something about the environment also. But where's the origin? Where does this all begin? So the actually first uses of machine learning and artificial intelligence seem pretty simple. They're just basic things like a linear regression. So on the right, we have a chart that actually measures, it reads out the height of a person in inches versus their weight. It's a scatter plot. So the question is, okay, how do we make sense of this data? This is the most elementary form of machine learning, if you will. And we draw a trend line. And so that trend line can not just be used to describe the data, but it can have some predictive power. So let's say that we say, okay, we have a new person whose height is 74 inches. What does our model estimate that their weight will be? And so there's this predictive power of basic numerical methods like a linear regression here. So that's the way that we can make sense of noise. But then the sort of next set and the stage of machine learning and AI is actually it's the same concept, just on steroids. So we have in the 50s artificial intelligence, like the earliest forms of it in a research context. In the 1980s, machine learning, mostly numerical methods like support vector machines or clustering algorithms. One big revolution in the 2010s was deep learning. So the introduction of more compute, bigger models, more data. They started using things called neural networks, which are very small, synthetic software versions of a brain's neuron. And if you put enough of them together, it starts to actually get kind of complex. It's like, think about taking that linear regression, but instead of just two factors, what if we did millions of factors and we had millions of lines? Could we get something that looks a little bit more like human intelligence? And then eventually generative AI, and we'll get into that in a second. So the GPT, you guys have heard of it, the T in GPT stands for transformer. And the origin of the transformer model was actually at Google Research when they were trying to develop a model for translation. And the way that conceptually the translation model works is it tries to use this very deep network to guess with probability weightings, what's the next word? So I love food. Just kidding. I love you. And so you can think that this would be the next word in a sentence. If you're translating, there might be different weights and different orders. Without getting too technical, there's this idea of a transformer, and a transformer model uses a metric called attention. And that's the T in generative pre-trained transformer. It's just a really big transformer model with more data, more capability.